Somewhere out there, about 1 trillion kilometers from where you're sitting, a chunk of ice the size of a mountain has been drifting in near total darkness since before Earth had oceans. It has no name yet. Nobody is tracking it, not because we're careless, because we can't. It's too far, too dark, too small against too much empty space. We won't know it exists until it's already on its way in. By the end of this, you'll understand why the most dangerous object in the solar system might be one we will never see coming. For most of human history, the edge of the solar system meant Saturn. Then it meant Neptune. Then, in the middle of the last century, a Dutch astronomer named Jan Oort looked at the orbits of long-period comets and noticed something odd. They weren't coming from anywhere close. They were falling in from a shell of icy debris so far out that sunlight needs about 1.5 years just to reach its outer edge. That shell has a name now: the Oort Cloud. It starts around 2,000 astronomical units from the Sun and may extend out past 100,000. 1 astronomical unit is the distance from Earth to the Sun. So we're talking about a boundary that begins 2,000 Earth-Sun distances away and doesn't really end. Everything we know about it comes from the rare comets it occasionally sends our way, and from the models built to explain them. Models that keep getting caught off guard. Here's the first uncomfortable part. The Oort cloud isn't sealed off from the rest of the galaxy, it's exposed. A 2025 study in the journal Astronomy and Astrophysics modeled what happens when a cluster of hundreds of thousands of ancient stars sweeps close to our solar system. Their scenario centers on a real cluster, NGC 7078, passing about 32 light-years from the Sun, roughly 332 million years ago. In the simplest version of their model, that one pass strips more than 1/3 of the Oort cloud's particles loose. Model the cluster properly as the dense, unevenly packed system it actually is, using over 1 million individual mass points instead of one averaged point, and the number climbs past 1/2. So what happens to a comet that gets shaken loose like that? Most of it scatters into the galaxy and never comes back. Some of it turns inward, toward us. And here's the part that gets me. The researchers behind this study point to something else. A separate 2019 finding, a documented jump in impact craters on the Earth and the Moon, dated to about 290 million years ago. 2 studies, different methods, years apart. Same slice of time. Not every dangerous object needs a whole cluster of ancient stars to wake it up. Some don't need anything we can predict at all. In 2023, astronomers pointed telescopes at an object called 2000 OG-44. For years, it had been listed as either a burned-out comet or a plain, inert asteroid. Nothing left to watch for. Then the images came back, and there it was. A thin tail of gas and dust stretching away from the Sun. Exactly what an active comet looks like. Nobody predicted that. There was no mechanism ready to explain it before it happened. It had simply turned itself back on, decades after we'd stopped expecting anything from it. If something we'd already given up on can do that, what does it say about the things out there we've never looked at twice? There's a hypothesis that makes this even less comfortable. 2 peer-reviewed studies, one from 2020 and one from 2024, propose that our Sun didn't start out alone. A stellar mass companion orbiting at roughly 1,000 astronomical units may have briefly shared the Sun's birth cluster with it before other passing stars pulled the two apart for good. This is still a hypothesis, not a settled fact. But if it holds up, part of what surrounds us right now was shaped by a star that vanished long before Earth looked anything like it does today. One that, according to the researchers, could be anywhere in the galaxy now. If we can lose track of an entire star and only find the evidence billions of years later in leftover comets, what are the odds we're keeping track of everything smaller out there? So picture the actual scale for a second. Voyager 1, the fastest, farthest human object ever launched, is expected to reach the inner edge of the Oort Cloud in roughly 300 years. Crossing all the way through it would take something like 30,000 years more. We built the fastest thing our species has ever made, and by the time it gets there, entire human civilizations could rise and end before it's halfway across. That's the space we're talking about. And it's not empty. It's loaded. Here's the catch in all of this. Nobody has ever actually seen a single piece of the Oort Cloud. Not one photograph. Its shape, its density, even where it actually ends, all of that is inferred from a handful of comets and the models built around them. There's even a recent claim that the cloud has spiral arms, shaped almost like a miniature galaxy. Real possibility, not confirmed. Nobody has peer-reviewed it yet. Here's the part that stays with me. We are a species standing on a small rock, orbiting an ordinary star, inside a bubble of ice that we've mapped almost entirely through inference and guesswork. Most of what surrounds our own solar system, by volume, is this thing we've never seen. That's not a reason for panic. It's closer to the opposite. Every uncomfortable gap in what we know has, eventually, turned into the next real discovery. The scientists modeling cluster passages, the ones who caught 2000 OG-44 waking up, they're not waiting for certainty. They're working from the edges of what's visible, the same way Oort did with a handful of odd comet orbits 70 years ago. Somewhere out past everything we can track, in the dark between our sun and the next one, something is still moving. It has been for 4.5 billion years. It doesn't know we're here, and it isn't waiting for us to notice.